Okay, in order to figure out if there's a hole or not, you need to factor the equation that you have, okay? In this particular equation, I can take out a 3. There's a common denominator, or a common factor of 3, so I can have 3 and then x minus 1. And then on the bottom, if you put x squared minus 1 in Desmos, x squared minus 1 in Desmos, we've got two zeros at negative 1 and 1. So I know that this would be x plus 1 and x minus 1 when I change those signs. Alright, once you have it factored, if there's something that cancels out, there's a hole. And there's a hole at the place that cancels. Okay? So you take whatever cancels, set it equal to 0, and solve. So on this problem, there would be a hole at x equals 1. Okay? Now, I'm going to go through and do all the holes for the problems, and then we'll come back and do the vertical and horizontal asymptotes. So on this one, this is already factored, so that's really nice. Are there any holes? No holes, because nothing factors. All right, the next one. We're going to have to put this one in. So x squared plus x minus 6. So I got negative 3 and 2. Let me do that again, negative 3 and 2. So I know that the top is going to be x plus 3, x minus 2. Okay, let's do x squared minus x minus 2. I got a negative 1 and a positive 2. So x plus 1, x minus 2. Anything cancels? The x minus 2's, that means that there's a hole at the place that it cancels. So there's a hole at x equals 2. Now, just because something factors doesn't mean there's a hole. For example, look at the next one. I can't do anything to the 2x squared, but I am going to do something to x squared minus 9. There's a negative 3 and a positive 3. So, plus 3 and minus 3. There's my factors. Anything cancel? Nothing cancels. So there's no hole. On this one, you can factor out an x. And then if you put that in Desmos and change the sign, you get that. X minus 2's cancel. So that's the part that you set equal to 0 and solve. So x equals 2 is a hole. On the next one, there's none. Because there's nothing you can do to that. That's just all you can do. Okay? I want to look at the next two, and the next two are kind of strange for us, or at least this one is, the x squared plus 1. If you put x squared plus 1 in, you notice that it doesn't cross the x-axis at all. That means that you can't factor it. That means that's all you can do to it. You can't do anything else. So this is another time where there's not a hole. And then the last one, this one is weird because it's not written as a fraction. And to figure it out, you might just have to graph it, and you still might not even know. But nothing really cancels, even no matter which way you look at it. So there's still no hole on that one. Okay. Mostly the times they're going to ask you about holes whenever they look like this. I want to tell you one more thing. It is possible to have more than one hole. Okay? Let's say that this was the problem after it was already factored out. These x minus 2's would go away. X plus 2's will go away. And there ends up being a whole at 2 and a whole at negative 2. So just because we think there can only be one, it's possible that there's two, and I just wanted you to see that. Okay, there can be more than one, and there can be more than one of the other things too. So, alright, let's talk about vertical asymptotes. Now, we talked a little bit earlier that we really could just graph it and look at it to figure out vertical asymptotes. So I'm going to go ahead and graph that first one. Oh goodness, I need to get rid of some stuff here. And then I'm also going to change the color here because I don't really like that color. Wow. It's hard to see what we're looking at, so I'm going to change it to a red. Okay. And that way we're not just looking at the black here. Alright, so here's the graph. What do we think the horizontal and vertical asymptote would be? Let's turn these back on. The green, I need to move it to about right there. Do you agree? And the purple, I need to move it down here. So about right in there. And so if you graph it, you can move your X and your Y to find what you need. And according to our graph, our vertical asymptote was X equals negative 1, and our horizontal was Y equals 0. Now, just very quickly, I'll tell you, whenever you're looking at the vertical asymptote is whatever is left over on the bottom where it equals 0. So like on this problem, how there was a 1 left over, the X plus 1 was left over, if I set that equal to 0, that's where the negative 1 comes from. It's wherever the bottom equals 0 that's left over from factoring. Okay? The horizontal asymptote's a little bit more tricky, but I really think graphing it will give you what you need. So let's look at the next one. And this one's going to be a strange one as far as the graph is concerned, so let's pay attention here. Alright, so we've got 2x plus 3, and then we've got x minus 1. Alrighty, we got some weird stuff going on, okay? There's actually going to be two horizontal or vertical asymptotes right there. Let's see. That looks like, trying to get close to it. See, it's not exact number, and this is one of those that is a hard one. I think it's negative 1.5. You can always press it and make it work. There's negative 1.5. That's a hard one where a decimal works. But see, there's one over here as well. Okay? So let's see. X equals, what do we think it is? 1 maybe? Does it look like 1 could be it? Yeah. And then the purple. Do you think the purple's at the right place? Yeah, it looks like the purple's at the right place. So there were two vertical asymptotes. There was a horizontal asymptote. This one was kind of weird. Okay? The horizontal we said was y equals 0. And the vertical we said was x equals negative 1.5 and x equals 1. Now what I told you was the vertical asymptote is where the bottom equals 0 that's left over from factoring. If you would have set both of those equal to 0, that's what you would have gotten, negative 1.5 and 1. Like if you take 2x plus 3 and put equal to 0, subtract 3, and then divide by 2, you get negative 3/2. That's that negative 1.5. So if you would rather just set them equal to 0 and solve, you can. Or you can just graph it and look at it. Okay, let's look at the next one. I can already tell what it looks like as far as factoring. Where do I think the vertical asymptote is going to be? we think it's going to be -1 because you can kind of look at it and tell. But we'll go ahead and graph it to make sure. X squared plus x minus 6. And then x squared minus x minus 2. Okay, I'm going to get rid of this last one because there's only one asymptote here. We think it's -1, so let's just move this to -1 and see. That looks right. The purple needs to come up some, right? Does that look like it's probably that? Yeah, let's make it even since it was a 0.9. There we go. Alright, and so we got x equals -1, which is what we thought. And y equals +1. Okay? So according to the graph, it looks like we've got a vertical asymptote at -3, at y equals 2, and then there's also another vertical asymptote over here. Looks like maybe at +3. So let's just check and see if that looks like it could be. Yeah, that looks like that could be, and so there looks like there's 2 vertical asymptotes on that one. On x squared minus 2x, x squared minus 2x. Alright, there it is. X squared minus 2x over x squared minus 4. Move that purple. It looks like it's around 1. Move the green that's over here negative something, maybe -2. So that looks like our vertical asymptote is x equals -2, and our horizontal is at y equals 1.